Intro. Hello and welcome to our video on the topic of current, electricity and magnetism. In this video, we'll explore the fascinating relationship between these two fundamental concepts in physics. Part 1. Current electricity. Let's start by understanding what current electricity is. Simply put, it is the flow of electric charge through a material, typically a metal wire. This flow is driven by a potential difference or voltage applied across the ends of the wire. When an electric current flows through a wire, it generates a magnetic field around the wire. The strength of this magnetic field is proportional to the current flowing through the wire. The direction of the magnetic field depends on the direction of the current. Electric current refers to the flow of electric charge through a material. The most common example is the flow of electrons through a metal wire. Electric current is measured in amperes, A, and is defined as the rate at which electric charge flows past a given point in a circuit. The flow of electric charge is driven by a potential difference or voltage between 2 points in a circuit. This voltage causes the electrons to move from the higher potential point to the lower potential point, thus creating an electric current. Electric current can be either direct current, DC, or alternating current, AC. DC flows in only one direction, while AC periodically changes direction. Most household electrical devices use AC, while batteries and electronic devices use DC. The flow of electric current through a material generates a magnetic field around the material. The strength of this magnetic field is proportional to the current flowing through the material. This relationship between current and magnetism is known as electromagnetism and has many practical applications, including electric motors, generators, and transformers. In summary, electric current is the flow of electric charge through a material, driven by a potential difference. It has many practical applications and is closely related to magnetism through the phenomenon of electromagnetism. Potential difference. The potential difference, also known as voltage, is the difference in electric potential between 2 points in an electrical circuit. It is the driving force that causes electric charges to move from one point to another. Potential difference is measured in volts, V, and is defined as the amount of work needed to move a unit of electric charge from one point to another in an electrical circuit. It is usually represented by the symbol V in equations and circuit diagrams. Potential difference is created by a source of energy, such as a battery or generator, which produces an electric field that causes electric charges to flow through a circuit. The potential difference determines the amount of current that will flow through a circuit, with higher voltage resulting in higher current. Potential difference can be calculated using Ohm's law, which states that the current flowing through a circuit is directly proportional to the voltage and inversely proportional to the resistance of the circuit. This relationship is expressed by the equation I equals V, R, where I is the current, V is the voltage, and R is the resistance. In summary, a potential difference is the difference in electric potential between 2 points in a circuit and is measured in volts. It is the driving force that causes electric charges to flow through a circuit and is determined by the source of energy and the resistance of the circuit. Ohm's law relates the current, voltage, and resistance in a circuit. Resistance and factor affecting resistance. Resistance is a measure of the opposition to the flow of electric current through a material or a device. It is typically denoted by the symbol R, and is measured in ohms, omega. Resistance is determined by the physical properties of the material or device and is dependent on factors such as the length and cross-sectional area of the material, as well as its resistivity, which is a measure of how well the material resists the flow of current. The resistance of a material increases with its length and decreases with its cross-sectional area. Resistance can be calculated using Ohm's law, which states that the current flowing through a circuit is directly proportional to the voltage and inversely proportional to the resistance of the circuit. This relationship is expressed by the equation I equals V, R, where I is the current, V is the voltage, and R is the resistance. The unit of resistance, ohm, was named after Georg Simon Ohm, a German physicist who first described the relationship between current, voltage, and resistance in 1827. Ohm's law is a fundamental principle in electrical engineering and is used in the design and analysis of electrical circuits. Resistance is important in electrical circuits as it determines the amount of current that flows through the circuit. By controlling the resistance of a circuit, the amount of current can be controlled, and this can be used to power devices or control their behavior. In summary, resistance is the opposition to the flow of electric current through a material or a device, and it is measured in ohms. It is dependent on the physical properties of the material or device and is an important factor in the design and analysis of electrical circuits. Ohm's law relates the current, voltage, and resistance in a circuit. The resistance of a material or a device depends on several factors, including length. The longer the material or device, the greater the resistance. This is because the current has to travel a longer distance, and therefore there is more opposition to its flow. Cross-sectional area. The larger the cross-sectional area of the material or device, the lower the resistance. This is because a larger area provides more space for the current to flow, and therefore there is less opposition to its flow. Material. The type of material used affects the resistance. Materials with higher resistivity, such as rubber or glass, have a higher resistance than materials with lower resistive aluminum as copper or aluminum. Temperature. The resistance of a material increases as its temperature increases. This is because as the temperature increases, the atoms in the material vibrate more, which makes it more difficult for the current to flow through. Type of circuit. The resistance in a series circuit is the sum of the resistances of all the components, while in a parallel circuit, the resistance is lower than the resistance of any individual component. Humidity. The resistance of some materials, such as paper or wood, can increase in humid conditions, as moisture can impede the flow of current. Light intensity. In some materials, such as semiconductors, the resistance can change depending on the intensity of light. These factors affect the resistance of a material or device and are important to consider in the design and analysis of electrical circuits. Understanding the factors affecting resistance can help engineers and technicians design circuits that are efficient and effective for their intended purpose.